This video will talk about how to name ionic compounds, but more specifically polyatomic compounds. The way to go about this is very similar to when you were doing binary compounds. So what we do is we start off with a particular compound. So let's say that the compound is magnesium cyanide. So you're given magnesium cyanide, and you need to try and find the formula for that. Now, I know that cyanide is not a typical element from the periodic table. It must be a group, which we call a polyatomic group. So do I need to memorize those? No. You have a resource to refer to, and it looks like this. It's attached in the lesson. And what you will do is you will go down the right column where you will find many polyatomic ions, and I will find where cyanide is. And there's cyanide right now. It is carbon and nitrogen linked together, and I notice there's a charge here, and it just says negative, and you assume that it's a 1. So the charge on cyanide is -1. So what I will do is I will write the formula for magnesium, Mg, and I will write the group cyanide beside it. Now, what I always do is I like to put my polyatomic ions in brackets, always. And I will get rid of the brackets if I need to in the end, but to start off with, leave the brackets on. Then I go and I take a look at the charge for magnesium, and I know magnesium is a +2. And we already saw that cyanide was a -1. And what I do is I write those above, and then what I do is I do the same as I did before. I crisscross, making sure that this 2 comes outside of the bracket. Let's see if I can get that to be a little bit more clear. There we go. And so what I do is then after the crisscross, I have Mg. Remember, I never write the 1. I'm going to leave my brackets, and I'm going to write my number outside the bracket. Now, it's really important that the brackets are there so that this indicates that you have 2 nitrogen and 2 carbons in order to make this compound magnesium cyanide. If you had left the brackets off, your formula would look like this, and that would be incorrect. The brackets must stay on. Now, going backwards, if you're given the formula, so let's say that you are given this formula, Fe bracket SO4, and there happens to be a 3 there and a 2 there. We need to try and figure out what the name of this compound is. I know that this is iron. I don't know what this is. And I always want to check, does my first element have more than one valence option? So what I'm going to do is I'm going to go back to this chart, and I'm going to take a look, and oh, sure enough, iron can be a 2 or a 3. Okay, keeping that in mind, I need to find out what the SO4 is. So I'm going to go down, and I see that SO4 is right here, and it's called sulfate. It has a charge of -2. So when I go back to my chart here, oops, there we go. I remembered that iron can be a +2 or it can be a +3. Sulfate was a -2. So when this compound was made, I have to ask myself, what option did they pick when they did the crisscross for iron? And I see that they picked a 3. So I know that I must specify a Roman numeral in this case. So I know that this is going to be iron 3. I know that this is sulfate, and I must make sure that it is 8 ATE, and that indicates to me that it's polyatomic. Normally, if it ends in "ide," it's a binary compound, but if you hear 8 or "ite," you know that it's most likely more than 2 elements forming the compound. So there we have it, iron 3 sulfate.